Algebra Brainiacs. Welcome to the Johnson Kendro video hour.
But it's not an hour.
Alright, here we go. Section 5.3.
This is our part 2 video that goes with 5.3. So we are going to learn a new special case today. It's the only thing we have left to learn in that factoring section. And it's called the sum and difference of cubes. So very similar to when we did the difference of squares. Here's an example of a difference of squares. To factor that, what we did is we said this is a perfect square. I would square root it. That would go in the first places. And then here I would square root this. That would go in the second places. And then the signs were always opposites. That was called a difference of squares. So what we're doing today is similar to that, but it's actually going to be related to cubes. And it's called a sum or a difference of cubes. Before we get going on that, I want to just quickly review what maybe some perfect cubes are. I think we're pretty familiar with perfect squares, but maybe not always perfect cubes. So if we take 1 and we raise it to the third power, Kendra, what do we get?
1 times 1 times 1 is 1.
That means 1 is a perfect cube. How about the next one? 2
2
times
times 2 times 2 is 8.
8 is a perfect cube.
3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed, I don't know. So let me get my handy dandy calculator out here, and it's 216.
How about
7 cubed, I do know that one, 343.
I don't think we need to go much further. Maybe you need to know that 1,000.
10 cubed is 1,000. Yeah. Otherwise, just do it on your calculator.
Yes, but those are helpful to be familiar with, to recognize those things. Okay, so here are our little forms here. Now notice this works for a sum or a difference, so it doesn't matter if it's a plus or a minus in between, this works, which is different than what we learned with difference of squares. So you're going to have something cubed and something else cubed, and our goal is to find out what those two things being cubed are. We will call those A and B. Once you find out what A and B are equal to, then you're just going to fill it in. So you'll notice it's A, B, A squared, AB, B squared. And that's the same pattern in either a sum or a difference. All that changes are the signs. So I've got a little memory trick for you to remember the signs.
Ooh, I like tricks.
Same, opposite, always positive is what you fill in. So if you look, this is a sum. So when you fill in the signs, there's 3 to fill in. Here's the same sign, so we use a plus sign. The opposite sign is what we started with, and then this third one is always positive.
Cool. You know what that spells? Soap. S-O-A-P.
Cool.
Yeah.
All right, here's a difference. And again, it's the same sign, opposite sign, always positive. So that'll help us fill these in. So the formula looks a little complicated, but it's really not too bad. All right, let's do some examples. Here we were just going to factor, and then eventually we will have Mrs. Kendra do some solving. All right, so I look at these two things. It's a binomial, 2 terms, and I'm going to see if they are, sometimes they could be squares, but these happen to be cubes. So that means that it is a difference of cubes. So remember, it's difference because there's subtraction in between. So my goal right now is to find out what is being cubed in each of these terms. So what my A is and what my B is. So what you're really doing is taking the cube root of each of those things. I'm going to take x cubed and cube root it. That would just get me an x. And then the cube root of 8, that would be asking what times what times what is that number? What is it?
2.
All right. All right. So now I'm going to factor it. It factors into a binomial and a trinomial. And you're going to just follow along with our little pattern here. A and B get filled in the first set of parentheses, so that will be x and 2 in this case. Then the next one is a squared. I maybe should be circling this one because it's a minus. A squared. So I'm going to take my x and square it. Then in the middle we do a times b. X times 2, that would just be 2x in the middle. And then b squared goes in the last place, so I take my b and square it. That's a 4. Last thing to do is to fill in the signs. So Kendra said we can use that soap.
We're going to clean it up here, people. Put in the same, opposite, always positive.
So same would be a minus sign because that's what we started with. Opposite would be a plus sign, and then the third sign is always positive.
Very cool.
And that's it.
Nice.
Yeah, not too bad. Okay, here.
Can I try one? Can I?
Sure. Let me get rid of all my writing writing up here. Okay, there you go.
Cool. All right. I'm going to check first to see if these are cubes. That and that. 27 is 3 times 3 times 3, so that is a cube. This is obviously a cube with the little 3. 64 is 4 times 4 times 4. So my A is 3x and my B is 4.
Because you cube rooted those terms.
Right. Now I see the plus, so that's going to match this one up here. So I'm going to make a little parentheses and a big parentheses.
Binomial and a trinomial.
Right. So A cubed, I would take this and cube it. Oh, I'm sorry, that would be 3x here. Don't need to cube it yet. It was cubed. And then the 4 goes here. Then I have to square this for here. Now I got to square both parts, the 9 and x squared.
Oh, I see. You got
Both
to
parts.
square the number and the variable.
Yep, and then the next one is 4, so that is 4 squared is 16.
Okay, and then in the middle.
In the middle I have to multiply them together. 3 times 4 is 12, so I have 12x. Now I want to clean things up with SOAP. SOAP, same. I have a plus. Opposite would be minus, and then always positive would be plus.
I see it's a little more complicated when the numbers are bigger and
Right.
the coefficient in front of your x cubed there.
So it's good to know and recognize your cube numbers.
Okay. So now that we've got some factoring practice under our belt, let's go down and use it to solve. So make sure you pay attention to the directions. If they say factor, you're just done once you have the parentheses. So when we solve, we want to make sure we have everything on the same side, so therefore set equal to 0. You will factor, like we just learned, and then you will set each factor equal to 0. And then I put a little hint on here. After the sum or difference of cubes, if you cannot continue to factor, which you're not going to be able to factor, we're going to have to use quadratic formula on the big set of parentheses.
Woohoo! We love that formula.
Oh, yeah, we do. So let's do one of those right now. So it says solve, and then we're going to have to find what the solutions are, and we're going to do this by factoring because it is a sum of cubes. This thing is a perfect cube, 27x cubed. If I were to take the cube root of that, that would give me 3x, just like the one Kendro did. And then 1 is a perfect cube as well. That means my b value is 1. So I'm going to factor it with the little parentheses and the big parentheses. A and B, just like they are. Then in the next one, I have to square the A. Remember, you're going to square the number and the variable. In the last one, you square the B, so that's just a 1. And then in the middle, you multiply them together. 3x times 1 is just 3x in the middle. It was plus, so I'm going to use the same sign, opposite sign, always positive.
Okay, when I see that equals 0, I always know I got to set each part equal to 0. If there's no equal 0, then you're done at this point.
So we need to set each factor equal to 0. 3x plus 1 equals 0. To solve this, we would subtract 1 and then divide by 3. So one of our solutions is negative 1/3. That was the easy one. Then here, when we set this thing equal to 0, it's a quadratic.
Normally we can do 2 little parentheses, but
these are actually not going to be factorable.
They're not going to be factorable, so
the way that we are going to solve is by using quadratic formula. I'll write that down for you just in case you forgot.
Who could forget that fun formula?
That's right. Okay, we're going to let our A be 9, B is negative 3, and C is 1. Plugging it all in. 3 plus or minus the square root of negative 3 squared minus 4 times 9 times 1, all divided by 2 times 9. So this is why we did so much practice on quadratic formula. Working underneath the radical, negative 3 squared is positive 9. I like to do the sign next. I've got a negative times a positive times a positive. That's going to stay negative. And then subtracting 4 times 9 times 1 is 36. All divided by, that's 2 times 9, which is 18. Still working underneath the radical. 3 plus or minus. I have 9, and I'm going to subtract 36. We get negative 27 in there.
Ooh, a negative.
All right, let's talk about that. Negative 27 in a square root. That is not a perfect square.
But it has one in it.
It does. So what we're going to do, first of all, I can take that I out because it's negative. I can divide that by 9, and And that is helpful because I know the square root of 9, it is
3.
3, so 3I root 3 is the simplified version of that. So now we've got this. Lots of 3's.
Heart surgery!
Yep, last thing we do is heart surgery. These are all divisible by 3, so final answer, 1 plus or minus I root 3 all over 6. Now, be careful. This was a polynomial that was raised to the 3rd power in the very beginning, so how many solutions should it have?
3.
3. Here is 1, and then technically, because of this plus or minus, that represents 2 solutions as well. So we have all of our solutions there.
Very cool.
All right, you want to try one?
Sure.
Okay, let's do that.
All right. Okay, I see 8 and a 125. Now, what clues me in right away is that cube right there. Then I start looking for cube roots. So 8 is 2 cubed. So my A is 2x. And my B is 5, because 5 times 5 times 5 is 125. Alright, then I do little parentheses, big parentheses. This one is A and B. This one is A squared.
Ooh, I like that you squared the number.
Thank you. And this is B squared, so that's 25. In the middle, it's A times B, which is 10x. Then we're going to clean things up with our soap. We got same, opposite, always positive. Now, because it's equal to 0, that means we got to keep going. We got to set them equal to 0. So I have this. I want to add 5. So I get 2x equals 5. Divide by 2. X equals 5 halves. There's one answer. I need 2 more. So I have this quadratic. Not going to be able to factor, so we put it in our quadratic formula. So negative b is negative 10 plus or minus b squared minus 4 times a times c all over 2a. So I have negative 10 plus or minus 100 minus 400 all over 8. Keep going a little bit more. 100 minus 400 is negative 300. So we have, let's see, we got 100 times 3 right here. Make that 100 times 3.
And it's negative.
Negative. That negative wants to come outside. All excited. Turns into an I. The 100 turns into a 10. I'm going to put that in front of the I. Square root of 3 stays. And then the 8. Next, I want to do heart surgery if possible. Looks like they're all divisible by 2. So negative 5 plus or minus 5I root 3 all over 4. That's pretty fun, I think.
So your 3 answers are right there.
Yep.
All
I
right.
got 2 here and 1 here.
Very good. All right, that'll do it.
That's pretty good for a day's work. We'll see you guys tomorrow.